In this video, we'll look at the Heathkit GR-64 Shortwave Receiver. I'll review the history of the radio, its features, and take a look at it inside and out. I'll discuss the restoration of this particular unit and demonstrate it being operated. Heathkit was well known as the premier manufacturer of electronics in kit form from the 1950s into the early 1990s. Their product line included shortwave and amateur radio equipment. At any given time, Heathkit typically offered several shortwave receivers in different price ranges. The GR-64 was an entry-level general coverage radio receiver covering the AM broadcast band and shortwave up to 30 MHz. It was offered from 1964 to 1971, initially at a price of $39.95. Typically, it was one of a range of shortwave receivers offered by Heathkit. This January 1970 Canadian Heathkit catalog has the GR-64 listed at $78.50, along with the GR-54 Deluxe receiver at $169.95, and the high-end GR-78 at $240.95, all in Canadian dollars. The successor to the GR-64 was the solid-state SW-717, introduced in 1971. The GR-64 is a tube-based shortwave receiver. It weighs in at about 12 pounds and covers the following frequencies in 4 bands. Band A, 550 kHz to 1500 kHz, the AM broadcast band. Band B, 1.5 MHz to 5 MHz shortwave. Band C, 4 MHz to 10.5 MHz shortwave. And Band D, 9.5 MHz to 30 MHz shortwave. This was an entry-level radio that sold for about half the cost of the GR-54 Deluxe receiver. Given that, it still came with a number of features that might be considered optional extras, including band spread tuning, S-meter, headphone jack, lighted dial, and automatic noise limiter. We'll look at how the GR-64 and GR-54 compare later in this video. The design uses 4 vacuum tubes and 2 semiconductor diodes. It runs on AC power and takes about 30 watts. It uses a 455 kHz IF frequency. Neither the manual or Heathkit catalogs published specifications for sensitivity or selectivity, but performance is comparable to similar receivers of this era. It can be aligned with or without test instruments. Like most Heath products, it was sold only as a kit. The front panel features a 7-inch illuminated slide rule dial. The dial is marked with various bands including amateur radio and shortwave broadcast, as well as the time and frequency standard station WWV. At the left is the uncalibrated band spread dial. If you're not familiar with the concept of band spread tuning, it's a secondary tuning control that allows accurate tuning of closely spaced frequencies of a radio band. On this radio, the band spread is uncalibrated and has set or 10 at the top and numbers up to 0 moving down. Typically, band spread is needed to tune single sideband or Morse code signals, and on the highest band where tuning is the most crowded. At the right of the dial is an S-meter indicating relative signal strength from 0 to 10. From left to right, the front panel controls are band spread tuning, power and volume, mode selectable to either AM, standby, or CW, band switch selecting one of 4 bands, BFO or beat frequency oscillator, and main tuning. The main tuning has a weighted flywheel and vernier augmented by the band spread for finer control of tuning. The internal speaker is mounted behind holes in the left side of the cabinet. The rear panel is made from thick cardboard, presumably a cost-saving measure. These often warp over time. On the left is the 2-wire power cord, followed by screw terminals for connections for the optional Q multiplier, antenna, and ground. Then there's the A&L, or automatic noise limiter, on-off switch. On the far right is a 1/4-inch headphone jack. The ferrite rod antenna on the back is used for the AM broadcast band only. For shortwave, you need to use an external antenna, although in a pinch it could be just a length of wire strung indoors. Inside, you can see that most circuitry is on a single printed circuit board. The PCB connects to the chassis using screws. Over time, these screws may need to be tightened to ensure a good connection. Some larger components, such as the power transformer, filter capacitors, tuning capacitors, and speaker, are mounted on the chassis and connected using point-to-point wiring. Additional wiring goes to the front panel controls. The use of a printed circuit board made assembly much less labor-intensive and error-prone, and overall a more pleasant experience than soldering all that point-to-point wiring. Heathkit said that typical construction time was 8 to 10 hours. Underneath can be seen more circuitry, including the band switch and the bottom of the printed circuit board. The radio uses the following tube lineup: a 12 BE6 mixer oscillator, 12 BA6 IF amplifier and BFO, 12 AV6 detector, audio amplifier, and automatic noise limiter, and a 12 AQ5 for audio output. It does a lot with only 4 tubes. The lack of an RF amplifier stage was the main design feature difference from higher-end receivers. It's interesting that the AR3, one of Heathkit's earliest shortwave receivers, uses almost the same tube set. The 455 kHz IF frequency allowed the use of low-cost AM radio IF transformers, but hurts image rejection on the shortwave bands. The BFO circuit is very simple, using a variable resistor that causes the IF amplifier to oscillate at the IF frequency when turned up. It's tricky to adjust as it's not very stable and interacts with the tuning. The power supply uses solid-state diodes in a voltage doubler circuit. The S-meter is not calibrated. It also reads upside down and backwards from common convention, indicating a value of 10 at the top for no signal and approaching 0 for strong signals. The A&L, or automatic noise limiter, is a simple circuit that uses a diode that conducts and clips the signal when it's too high. It's not particularly effective, but it is low cost. This circuit only uses 1 diode rather than 2, so it would have been very poor indeed. I suspect that the designers found that they had an extra diode element available unused in the 12 AV6 tube and decided to add A&L since it only required the addition of a switch. Having it listed as a radio feature may have been more of a marketing gimmick than a useful feature. Placing the switch on the back also implies that it would not often be used. The operating instructions section in the manual doesn't even mention the A&L control. There's a connection on the back for an optional Q multiplier. The GD-125 sold for about $25 and increased selectivity, making the radio more suitable for receiving Morse code signals. I'm hoping someday to acquire one of these. The GD-125 will work with a number of Heathkit radio models or non-Heathkit radios, provided that they use a 455 kHz IF frequency. I bought this radio on eBay in April 2014. It came without a manual, but I found a partial manual and schematic on the internet. I was concerned when I first received the package as the box rattled, not a good sign for a tube radio. Opening it up, I found that some tubes were out of the sockets and the heavy power transformer had come loose. There was no visible damage though, and all parts were there. Other than the usual scratches and small cracks around the plastic front panel, it looked to be in pretty good shape. When initially carefully powered up using a variac, it picked up several AM stations. The shortwave bands didn't seem to be working well, if at all, and the S meter was off scale. A check of the components showed that most resistors had drifted up in value, as is normal for these old carbon composition types. I replaced a few that were 20% off or more. I figured that was the likely cause of the S meter problems, as it uses some resistors as a voltage divider to compare the AVC voltage to a reference value. However, that did not fix the problem. I spent considerable time poking around, checking components and wiring. I even tried swapping some of the tubes with known good ones from a Heathkit AR3. After lifting several resistors in the AVC circuit, there was still a resistance of about 60K to ground that should not be there and I could not account for. The printed circuit board really had a lot of rosin flux residue on it. On a hunch, I scraped some of it off and the mysterious resistance to ground went way up. After cleaning the board with alcohol to remove the flux, the resistance became too high to measure. The S meter also started reading on scale. Out of this was a lesson learned. Flux residue can cause problems in high impedance circuits. Obviously this flux was there since the kit was built, but whether it caused a problem from day one or only later, who knows. The next problem was that it was dead on bands other than AM. Actually, band D was working, but poorly. A check with a scope showed that there was no local oscillator activity at all on bands B and C. All the coils looked good, but I was seeing a low resistance between the local oscillator tuning capacitor and ground on bands B through D that should not be there, according to the schematic. The local oscillator frequency on band D was also way off. After a bit of tracing of the circuit, I found the cause. Two wires that crossed were touching where there was insulation missing and were shorted. One was the antenna lead and the other was from the local oscillator. After pulling them apart, the local oscillator started running on all bands. While I can't be sure, it appears that the radio had this fault when I received it, making me wonder if it ever worked properly on the shortwave band since it was assembled. I gave the unit a good cleaning inside and out. Some knobs were hard to turn, but loosened up after being cleaned and lubricated and operated for a while. The case was scratched and a little dented. I straightened some bends in the cover. The plastic front panel on these units cracks easily. Almost all the units I see up for sale on eBay have cracked panels to some degree. This unit is a little better than most and has only a little cracking of the front panel. The cardboard rear panel was quite warped. I removed it, dampened it, and pressed it flat for 24 hours to reduce the warpage. As well as the usual Heathkit model sticker, there's a second sticker on the back for a GR-72, which was a long wire antenna kit. This was a kit that sold separately for $3.25 in my 1970 Heathkit catalog. Some pieces of the ferrite antenna were chipped and I found them in the box and inside the case. I glued the pieces back with super glue. I also replaced the plastic retaining clips that had become brittle and started to break. This radio does not have any wax paper capacitors, so I did not have to replace any. The electrolytic filter caps tested okay, so I left them. I put a trimmer pot on the voltage divider circuit for the S meter so that it can be adjusted to 0 for no signal. The position varies slightly by band, but it works okay. The AGC action is a little too fast, as indicated by the meter bouncing up and down with audio. This is a known issue with the design and could be fixed with a larger cap in the AGC filter circuit. The radio can be aligned without test instruments, a nice feature for someone who doesn't own test equipment. The procedure relies on tuning to stations on each band with known frequencies. This would be a little tedious and challenging. For example, some bands are only active at night and others during the day. You would also need a decent antenna. I did a full alignment with instruments using an accurate DDS signal generator and oscilloscope, and it all went well. I could align each band at each end of the dial. Because of the low 455 kHz IF frequency, you have to watch out that you don't align to the image frequency that's only 910 kHz away from the correct one. The manual mentions this in the procedure, but I almost did this on one band and thought at first that I could not get it to align correctly. It's important to follow the alignment procedure as indicated in the manual, as the band D alignment affects bands A, B, and C and needs to be done first. One of the trimmer caps had the slot snapped off, making it hard to adjust. I removed the central core and cut a new slot into it with a hacksaw. The radio is better than some models in that it is aligned at both ends of each band, so accuracy of the dial pointer is pretty good when accurately aligned. Some radio models align a band in one place and hope that it's not too far off on the other end of the dial. Let's listen to the radio on the air. I have it connected to my outdoor amateur radio dipole antenna. Band A is the AM broadcast band. We can pick up a few local stations that are broadcasting here in Ottawa, Canada.
1200. You lose. He went into your house and kicked your...
On shortwave band D, we should be able to pick up a number of shortwave stations this evening around the shortwave broadcast bands.
Tremendous anticipation.
Tome medidas para lograr un acercamiento con el gobierno de Cuba.
The GR-64 was one of Heathkit's entry-level shortwave receivers. The radio is reasonably sensitive and can pick up lots of shortwave broadcast signals with a decent antenna. It would not be very suitable for serious amateur radio use, as bands like the 40-meter ham band only take up a small portion of the dial. The BFO is also hard to use, as it is not very stable and interacts with other controls, so it could be used for strong CW signals, but would be frustrating for single sideband. The lack of selectivity would be somewhat improved by adding the optional GD125Q multiplier. It's interesting to compare it to the GR-54, which was built as a deluxe receiver and sold for about twice the price of the GR-64. As you can see, the two receivers look very similar. What did you get in the GR-54 for the extra cost? 6 tubes versus 4, 5 bands rather than 4 including long wave, an RF amplifier stage, better sensitivity, a crystal filter for better selectivity, a product detector rather than a BFO, an antenna trimmer control, front panel A and L switch, a larger speaker, and it included the GRA72 antenna kit. I've made a separate YouTube video on the GR-54 that you can view if you're interested. In summary, while a low-end radio, for the price, the GR-64 was a good value, a fun kit to build, and got many people started in ham radio or shortwave listening. Thanks for watching. If you enjoyed this video, check out my other YouTube videos on vintage amateur radio and test equipment.